Hello and welcome. Today I would like to walk you through insights that FLIR Systems has developed for supporting our customers in developing fugitive emissions monitoring plans relevant to U.S. regulation that has come about here in the past 18 months or so. Specific to the U.S. regulation today, we'll be talking about the EPA New Source Performance Standards Quad OA methane rule, as well as the Bureau of Land Management venting and flaring rule. We have developed through our subsidiary, the Infrared Training Center, a Quad OA specific training course as well. So today's presentation will be a shortened, revised version of some of the content that we cover in much more detail in our full-day Quad OA course. You can find more information on the ITC Quad OA course at infraredtraining.com. And this course was also co-developed by one of our customers at Leak Imaging LLC. So first we'll take a look at the EPA NSPS Quad OA rules and regulations and how it came about and what the timeline associated with it is. As you can see here, this is a regulation that focuses primarily on reducing methane emissions at onshore oil and natural gas facilities. It was promulgated into law and entered into the Federal Register on June 3rd, 2016, and applies to facilities constructed, modified, or reconstructed after September 18th, 2015. So for the most part, facilities that were built or constructed or went into production prior to that date in 2015 do not have requirements to comply with the Quad OA regulation itself. When we look at some of the affected sources for the Quad OA regulation, you can see it's a variety of different sources from completions at hydraulically fractured wells, compressors, pneumatic controllers, pneumatic pumps, and a variety of different produced water storage tanks. What we're going to primarily focus on today during this presentation is the aspect of Quad OA that touches on fugitive equipment leaks. And this obviously is very relevant to FLIR technology and that we build and create optical gas imaging equipment that empowers industry to be able to find and repair leaks. And the regulation specifically calls out requirements at natural gas well sites as well as compressor stations. With regards to the timeline, you can see here at the bottom, this goes into effect June 3rd of 2017, where initial fugitive leak monitoring surveys must be complete by that date on the calendar. Also, for new production sites or new facilities, whether they be well sites or compressor stations that start up production after this date in 2017, then the initial survey must be complete within 60 days of that startup of production. We'll take a quick look here at some of the monitoring requirements specific to the leak detection. You can see here in the Quad OA standards, they call out what they call a BSER. So a BSER is essentially what the EPA states as a best system of emissions reduction. So when you look at well sites specifically in the United States as well as compressor stations, both production, gathering, and boosting stations, they have outlined optical gas imaging as the technology of choice, designated as the best system of emissions reduction based on their cost-benefit analysis. The frequency is dependent on the source. So for oil and gas well sites, optical gas imaging is required on a biannual basis, whereas it's actually required on a quarterly basis for compressor stations. It is important to note that they did write into the regulation alternative methods that are allowed as opposed to optical gas imaging, and an alternative method for leak detection at well sites and compressor stations is and would be method 21. They do identify that you've got to have a threshold of 500 ppm or above when using method 21, so that's a bit of a shift to some of the higher thresholds that have been used in previous regulations. Also wanted to touch on the fact that the United States Bureau of Land Management, or the BLM, has also put out their waste prevention production subject to royalties and resource conservation rule, which is commonly in industry referred to as the venting and flaring rule. This was published into the Federal Register on November 18th, 2016, and is applicable to oil and gas production operations on federal land. It also includes tribal lands. So if you look at a map of federal and tribal lands, this is much more applicable to the western half of the United States, just based on where those lands are located. One big thing to note here, and how this rule really varies considerably from the EPA Quad OA rule, is the BLM rule applies to both existing as well as new production operations. So the existing aspect of it is a big differentiator there. Very, very similar to Quad OA regulations, the BLM rule does require instrument-based leak detection, and they specifically call out optical gas imaging as a preferred method as well. When you look at the specific requirements, the cadence of inspections, the sources that it's relevant to, it is very similar, if not almost identical, to the EPA and SPS Quad OA regulations. And because of that, they've specifically stated in the regulation that any operators meeting Quad O or Quad OA regulations are actually deemed compliant for the BLM rules. So good news for anybody that has equipment that is applicable to both rules. Obviously, you only have to meet Quad OA, and by default, you will meet the BLM rules as we understand it as well. For any existing equipment that was built before, I believe, the September date in 2015, where Quad OA does not apply, that's where essentially you would shift into compliance for the BLM rules, specifically if it's on federal or tribal lands. The initial fugitive leak monitoring survey must be completed by January 17th, 2018 for the BLM rule, or similar to Quad OA, within 60 days of startup of production on a new facility. So moving on to some of the fugitive emission components as outlined by the EPA Quad OA standard, and the definition of these fugitive emission components. This is pulled specifically from the regulation itself. Essentially states any component that has the potential to emit fugitive emissions of methane or volatile organic compounds, VOCs, at a well site or compressor station, including but not limited to. And you can see the long list here. So most everything that has the potential to emit fugitive emissions is going to be considered a fugitive emission component. One thing that we do note that is called out specifically in the regulation is devices that vent as part of normal operations, specifically natural gas driven pneumatic controllers or natural gas driven pumps are not considered fugitive emission components. And this primarily means that any natural gas discharge from the devices is not considered a fugitive emission. It's up to interpretation as to what you would need to document every time venting is actually seen as part of normal operation, and I would recommend you advise with your internal environmental group to determine the best path moving forward in that situation. One thing that is a big kind of overarching theme when it comes to the specific methane regulations is the need to develop a fugitive emissions monitoring plan. And this is something that we primarily focus on here in the remainder of this presentation, as well as in our Quad OA specific course. They do state that a fugitive emissions monitoring plan must be developed for well sites within a company-defined area, which could be construed as somewhat vague. We did pull out some descriptors of how the EPA looks at a company-defined area from the regulation itself. I believe this was maybe in the preamble. They describe it as an area located within close proximity, under common control within a field or district, or managed by a single group of personnel. Also, general requirements, there's a long list of things that need to go into this monitoring plan prior to any type of survey or inspection. And you can see the list here. Everything from frequency inspection, which is called out as a requirement, quarterly for compressor stations and biannual for well sites. Obviously, the technique or the technology used for leak detection, so this would primarily be either method 21 or optical gas imaging. The manufacturer of the equipment to include model number, serial number, calibration date. And then they walk through and say, okay, you know, you also need to outline specifically what your procedure is going to be, along with associated timelines for repairs. The record-keeping requirements here are 5 years, and they want you to obviously put that into the monitoring plan so that everybody within the organization is on the same page. And then they actually have some requirements for you to outline the training and experience of the operator along with procedure for calibration and general maintenance. And we'll touch on that a little bit here in subsequent slides. So also digging into the fugitive emissions monitoring plan requirements, four of the probably the biggest things that we feel like FLIR can offer some insight into from our perspective is probably the four biggest requirements for these monitoring plans is requirements for processes to define initial and daily verification checks for the equipment you're using for optical gas imaging. Also determining max wind and distance during inspections, ensuring adequate thermal background is achieved during inspection, as well as calibration and maintenance protocols. We'll talk about that here in the next couple of slides as well. One thing that is interesting is the requirement for operators in their fugitive emissions monitoring plan to develop a site map that includes an observation path. And you can see the spirit of this requirement is essentially to assure that operators look at all the required components, but they did state that they have made some efforts to reduce the burden of tagging and logging associated with traditional Method 21 or sniffer programs. So I think everyone would, for the most part, primarily agree that optical gas imaging is much more efficient in leak detection since you are using a non-contact technology to be able to see emissions visible through a camera, and you don't have to actually make contact with a specific component to be able to determine whether or not it's leaking. However, it is reasonable from the EPA standpoint that you determine what your observation path will look like, what your walking path essentially is going to look like as you walk around the facility and make sure you're within a reasonable distance of components that you need to periodically inspect. And there are also specific requirements for GPS tagging, which is an interesting requirement as well. So any documentation that is taken from the site would need to incorporate a digital camera image. It can be either an infrared image from the FLIR camera or a visible image from the FLIR camera as well that needs to have embedded GPS information into it, which with most all FLIR cameras is a basic feature that's incorporated into the GF series, so not an issue there. If there are no leaks detected and you are not required to essentially save any videos or images, if there's no leaks detected, then you're still required to at least take one visible image or digital camera image from the facility with your optical gas imaging camera that has GPS tagging built into it to prove that you were on site at that given day. One big aspect of this regulation that came about is essentially what's referred to as an initial verification check for your optical gas imaging equipment. This is essentially a requirement that you use equipment that is up to snuff when it comes to the EPA's requirements for ability to see gas, right? And I believe the intent of this is so that you're using technology that is specifically designed for gas imaging as opposed to maybe just a general infrared camera that really, for the most part, cannot see any type of gas compound but still sees infrared energy. So this is an attempt to kind of make a definition of what optical gas imaging equipment actually is and what requirements it can meet. So if you look at the requirement here, it says your optical gas imaging equipment must be capable of imaging gases in the spectral range for the compound of highest concentration in the potential fugitive emissions. In most natural gas production environments, methane is going to be essentially the specific gas of the highest concentration in the fugitive emissions, and the GF320 as well as the GF300 and the new GFX320, which is the intrinsically safe version of our technology, is very, very tuned to be able to see methane, so obviously meets this requirement. Then the other requirement is that your OGI equipment is capable of imaging a gas that is half methane, half propane at a concentration of 10,000 parts per million, also at a flow rate of less than or equal to 60 grams per hour from a 1/4 inch diameter orifice. And they specifically state that this verification can either be performed by the facility, by the manufacturer, or by a third party. So it puts the onus either on the operator itself or the manufacturer specifically of the equipment, which would be FLIR in the case if you're using a GF300, GF320, or GFX320. And so this is where we feel like FLIR can offer some support to our customer base. We went through great strides in 2016 to contract out a third-party organization by the name of National Physical Laboratory in the UK that's got vast experiences in optical gas imaging and infrared technology in general, and paid for an independent test report to be created specific to the GF series cameras, and essentially had them certify that it is essentially able to see the flow and mixture and concentration of gas that's required in the Quad OA specific initial verification check requirement. And so since that process was completed, we've put a certificate on our website. You can see it's at FLIR.com/OGI, and this applies to the GFX320, the GF300, the GF320, as well as our fixed-mounted continuous monitoring cameras such as the G300A. And if you download that certificate, you can see that there's a variety of things that it should support you in developing your fugitive emissions monitoring plan. It essentially touches on calibration requirements and that there's no calibration required for these cameras when using them solely for gas detection. Also says what gas compounds they're able to detect, and obviously methane's included in that. And then it has the MPL statements that the camera technology is able to see the flow of gas required by the EPA. To reiterate on the calibration requirement, it is very, very important to note, and I believe this has maybe been misconstrued in the past, that when we look at most optical gas imaging equipment out there in the marketplace, but specifically FLIR optical gas imaging equipment, there is no calibration process that has any bearing on gas detection. The camera is built from the ground up internally by FLIR, meaning that we manufacture the detector, we manufacture the internal filter, the optics, the electronics, the entire camera. We're fully vertically integrated, and when we build that camera from the ground up with a specific methane or hydrocarbon filter built into the camera, it blocks out all other energy we do not want to see, and it allows energy to come through that corresponds with the absorption characteristics of the gas compounds that we're looking to visualize. So there's no degradation over time of that filter, similar to a calibration process that's essentially going to mean that you would, see gas less effective one day versus the next. It's just not the case. And so we put this specifically in our manual now, and it says no calibration recommendation at all if you're using the camera for gas detection. And that's, again, because the ability to detect gases is not influenced by the calibration and will not degrade over time. On the flip side, these cameras, for the most part, are calibrated to measure temperature, which is somewhat of a dual benefit of the technology. FLIR has got a long history of building calibrated infrared cameras, and we're the market leader in that realm worldwide. And so it makes sense for us to be able to put our OGI cameras through a calibration process to offer that added benefit to our customers. For maybe preventative maintenance applications where you actually need to know the temperature of a certain object. And so if you are trusting and relying on temperature measurement, we do have a recommendation in our manual that you have this periodically recalibrated, because like any calibration process, there's always some propensity for drift over time. Another requirement in the EPA Quad OA regulation is an optical gas imaging daily verification check. So we also updated our manual here because the EPA specifically does not require any gas release, does not call out a requirement for a gas release when verifying that your optical gas imaging camera is working on a given day. But it does seem reasonable for you to have built into your fugitive emissions monitoring plan a process to make sure that your camera is functioning as intended by the manufacturer. So we've got a general instrument check that we've built into our manual, and you can see here it's a basic 5-step process that, again, does not include a gas release, so that you can do this on a daily basis prior to your inspections and still be compliant with the EPA regulation. Other methods we've seen many customers use over the years is something as basic as verifying that you can see the emissions from a butane lighter. And it's also important to note that for the most part, standard hand sanitizers out there in the marketplace have components in there that allow the camera to be able to see emissions coming off your hand or coming off of the liquid itself. And you can see here when we enter into the high sensitivity mode in the camera, you can actually see the small vapors and emissions from a hydrocarbon perspective coming from the hand sanitizer. So another great way to just do a quick verification that your camera is up to snuff if you're not going to walk through the 5-part process in the FLIR manual. So one of the big aspects and big requirements built into the EPA Quad OOOa standard as well as the BLM standard is a need to determine both a max wind speed for inspections as well as a max distance that you believe your operators can operate optical gas imaging technology effectively to be able to find fugitive emissions at your facility. This is an interesting requirement because if you read the way the regulation is written, it does really put the onus specifically on the operator themselves. There's many requirements built into this, and in my opinion, it does not necessarily give leeway for manufacturers to completely set this standard because there are potential for interferences and things like that that could come into play when using optical gas imaging equipment. With that said, FLIR did feel that it was worthwhile for our customer base to provide some data to do some third-party testing again, which we did through National Physical Laboratory or NPL, to just determine when in certain environments you should be able to see fugitive emissions, and in other environments maybe it would be reasonable that you wouldn't be able to see those fugitive emissions, thereby informing or instructing your operators that maybe they should get closer or try to block the wind, or maybe even use the technology on a day where the wind is not quite as prevalent. And so you can see here this basic chart gives somewhat of a summary of the performance parameters that were tested in the MPL test report. And generalizing this a bit, you can see as long as there was a thermal background between the gas temperature and the background scene, right? So in most cases, ambient air temperature can be used as a surrogate for gas temperature because the gas in the ambient air equilibrates to air temperature very rapidly. And so in this scenario, you're essentially doing an analysis to say, okay, the object behind a fugitive emission component that I'm trying to look at must be either greater than or less than more than 4.5 degrees Fahrenheit than the ambient air temperature. So I would say this is a fairly minimal thermal background, but very relevant as well. And you can see here there's specific requirements that our MPL folks went through and did some testing on with regards to distance and wind speed. And in most situations when you are dealing with winds under 20 miles an hour, or the MPL test shows that they could effectively see the gas release of methane and propane at 10,000 parts per million, so the same gas release that's called out in the initial verification check. They were able to see that very effectively at these distances and those wind speeds. You can see in the scenario in the very far bottom right, wind speeds at 20 miles an hour and distances of 65 feet. It was just too challenging to be able to see that small of a gas release. Now, one thing that is important to keep in mind here is we chose to go with the more rigorous gas release just to make sure that in this MPL test report, it would provide data on really one of the more challenging requirements to try to meet. Again, a diluted stream at 10,000 parts per million of split methane and propane. While we realize that that is not necessarily at all indicative of what's actually in a normal gas process stream, where you'd have a much higher concentration than 10,000 parts per million, we still felt it was relevant to actually match the release that was specifically called out in the initial verification check. So hopefully this is construed as very, very stringent parameters that have been met with regards to this gas release at these distances and at this wind speed. The full report that was developed by MPL and provided to FLIR can be sent out upon request. Just reach out to your local salesperson and we'll get that to you as well. You can find that information at FLIR.com/OGI. One question we get is, okay, if you need to be over 4.5 degrees Fahrenheit or below 4.5 degrees Fahrenheit from your background temperature, and just make sure you've got an absolute delta T of that amount, how do you verify that? Well, one way to do it, and I will state that this is one way to do it, there are other ways to do it, would be to leverage FLIR calibrated camera technology. So the GF320 as well as the new GFX320 are both, again, calibrated to measure temperature. So this is a very effective way for you to essentially use and leverage that temperature measurement to be able to measure the background temperature of whatever your target is behind your fugitive emission component and compare that to the ambient air temperature. So here's a basic 3-step process that allows you to do that. If you set your emissivity at 1 and measure the temperature using an area average box, so that will obviously average the entire area within the box that's chosen and give you a basic average temperature, and then actually use a different tool to measure ambient air temperature. FLIR through our test and measurement line and the X-Check instruments line has a variety of different ambient air temperature measurement tools that you could use, and now do a very basic calculation to determine delta T. So determine what the absolute value is of the box average minus the ambient air temperature, and that'll tell you what your delta T is. So as long as you're above 4.5 degrees Fahrenheit in either direction, then it would be reasonable to essentially leverage the information provided on the previous slide, which showed the MPL testing and the associated parameters where they either were able to see the emissions or were not able to see the emissions. It is very important to always have your operators ensuring that they've got adequate thermal background, and that's one thing that you can follow a clear list of steps to be able to really try to train folks to be able to achieve this. We go through this in great detail in our training courses, both our 3-day optical gas imaging training course as well as our 1-day Quad OA training course through the Infrared Training Center. And some just general suggestions that we offer in this training class. We go through it in much more detail obviously in the class, but general suggestions are to avoid vegetative backgrounds. As you can imagine, air temperature and most vegetation, whether it be grass or trees or foliage, are very, very, very close in temperature. So you're going to have a minimal delta T when your air temperature is very, very similar to your background. So trying to avoid these vegetative backgrounds is always a good rule of thumb. In general, just scanning from multiple angles to try to change that viewing angle, which is always going to keep some variation with regards to your delta T values, is a good idea. Storage tanks, usually you're shooting them from the ground, looking up, trying to see thief hatches and Nardo valves, whatever it may be, looking for fugitive emissions. In general, it's always good to try to use clear sky as a background. Sometimes it can be a little bit more challenging if you've got a lot of cloud cover. Clouds are obviously built with water molecules, and water has strong IR absorption in the bands that we're looking at as well, so sometimes it can kind of create some interferences. So nice to have a clear sky background when possible, and obviously because of that, be aware of the effects of overcast and humid days. One great way to really overcome a low delta T is using high sensitivity mode. This is a patented proprietary program built into the FLIR cameras that essentially does a variety of different image subtraction and image averaging techniques to be able to accentuate cloud movement. So if you've got emissions, big or small, it makes it much, much more easy to see those small emissions when you're using high sensitivity mode, even with a low delta T. And then another one is, if you've got a low delta T, it makes sense to decrease the distance to the component, get as close as you can while still remaining in a safe operating procedure. Other things to take into consideration, obviously some areas in the U.S. have consistently higher wind speeds than what we did testing on in the MPL test reports. So we're by no means saying that just because MPL testing only went up to 20 miles an hour, does that mean that this technology is only worthwhile up to 20 miles an hour? That is by no means true. That's just as high as the MPL testing report went. And there are areas in the U.S. that have consistently higher wind speeds than 20 miles an hour, and we recognize that. Individual operator experience and eyesight can vary, and we see that across the board. And again, we'll touch on this, the concentration, which is 10,000 parts per million of hydrocarbon of the release tested during the NPL report, is likely much, much lower concentration than what you would actually come into in an actual production stream. So again, I would say that's a very conservative test that is probably more challenging than it ultimately needs to be. So because of those considerations, our customer Leak Imaging in the co-development of the Quad OA course developed their own method for essentially determining max wind and distance while on site at each given location. So this is also another method that I would say is a commonly used practice in the industry to be able to determine, okay, on a given day, what is it reasonable for us to do an inspection at with regards to wind speed and distance based on some testing that we're actually going to do at that facility. So fairly basic, fairly simple gas release on site can actually, in our opinion, meet the requirements that the EPA rolls out in the EPA Quad OA standards, which also applies to the BLM regulation as well. Again, this involves a simple propane gas release on location and essentially covers the following requirements all in one procedure. It establishes max distance, max wind speed, allows the operator to assess the impacts of other environmental conditions, for instance, fog, cloud cover, ambient air temperature, etc., and then also checks the box for the daily verification check. So here's the process that Leak Imaging walks through in their procedure. They essentially have a 1 pound cylinder of propane, and they verify that a 60 gram per hour release, which is also the same as a 0.508 liter per minute release, can be seen in current weather conditions. So essentially a process where you go out to a location, you set up a cannon of propane to release at 60 grams per hour, fire up your camera, start to walk away from that gas release and determine, okay, in today's wind conditions or right now's wind conditions, what's the max distance that I can still see this gas release? Document, obviously, that procedure very explicitly. Document your wind speed. Periodically check to see if your wind speed is changing drastically. And now you've got a new max distance, even if it's maybe 30 miles an hour or 35 miles an hour on that given day, and you verify, you know what, I can still see that gas release of propane at 15 feet away. Well, then that should set your guideline for the day. Assuming that your wind speed stays that high, you would need to be within 15 feet in that scenario, right? This also takes into account operator eyesight, operator experience, operator training. I would always recommend to document your weather conditions as well. And again, we'll touch on this. We go through all of this in much more comprehensive detail in our Infrared Training Center Quad OA course. And information can be found on infraredtraining.com. We do these courses all over the country, so from Colorado to California to the Boston area, Marcellus Shell up there in Pennsylvania, and obviously all over Texas. We do these courses in the field as well as in our formal facility in the Nashua, New Hampshire office. And this is just a quick chapter overview of what we cover in that course. You can see here we cover, again, in much more detail everything that I talked about here today, along with a series of training applications and examples. And the last thing we will touch on is what we referenced here multiple times during the presentation is the new FLIR GFX 320, which is the only intrinsically safe camera that is an optical gas imaging camera designed specifically to see hydrocarbon gases. And so this is a technology that we're very excited of, very proud of, and for more information, reach out to your local salesperson or go to FLIR.com/OGI. Thank you for listening, and we will follow up with the series of additional training, webinars, and presentations here in the coming months. Thanks so much. Bye.